Okay, in Chapter 5, we learned about discrete random variables and their distributions, but now in Chapter 6, we're going to talk about continuous random variables and their distributions. So, you know the difference now between discrete and continuous variables, so that's really the big difference now, is instead of talking about discrete variables, we're talking about continuous variables. But along with that, there are other differences in terms of calculating probability, which is extremely important. So the thing that we're thinking about now is with discrete random variables, we're able to calculate the probability of a particular value, right? So that's what we're able to do. So if you think about, sorry about that, this distribution here, right, this is from Chapter 5, right, what is, the probability of a customer making a purchase, right, 0, 1, 2, or 3, right, it could take on any of those values. So we could say, hey, what is the probability that number of customers, that one customer makes a purchase? But with continuous random variables, we can't actually say what is the probability of one specific number. Instead, what we have to do is we have to calculate the probability of an interval. So we'd say, hey, for example, think of a continuous random variable. So we might think of the weight of a shipment. So we can't say, hey, what is the probability that the shipment weighs 100 pounds? We can't actually do that, and I know that's a little confusing, but I'm going to show why in a little bit. But instead we have to say, hey, what is the probability that the shipment weighs between 100 and 200 pounds? So that is a huge difference, right? So again, with discrete random variables, we could say, hey, what is the probability of one particular value, but with continuous random variables, we can't. Instead, we have to say, hey, what is the probability of, some interval? So like I said, the weight being between 100 and 200 pounds. The reason for this is because you can look down here. This is a continuous distribution, right? It's this is a normal distribution, but they don't have to be normally distributed. So in order to calculate a probability, what we do is we calculate the area under the curve. So when you think about the area under a curve, if you have 2 points, right, maybe a line here, right, if we're looking again at the shipment weights, right, at 100 and 200 pounds, what we do is we find the area under the curve for that given interval. So if you think about it that way, that's how we calculate the probability, it now makes sense to think about, well, what's the probability of one value? Well, one value is only one dimensional. To calculate area, we need 2 dimensions, right? Length times width, for example, right? But with one point, you might have a length, for example, but you wouldn't necessarily have a width. The width would be equal to 0. So what would be the probability of that? It would actually be 0. So if you say, with a continuous distribution, hey, what's the probability that the shipment weighs 100 pounds? Well, it's 0. So instead, what we do is we calculate the probability for an interval with continuous random variables and their distributions. So that's a pretty big difference for that. So in the next video and over the next couple of videos, actually, I'm going to show you, right, how we do this, how we calculate the area under the curve in order to calculate probabilities. Because remember, these chapters, discrete and continuous, and then we talk about sampling distributions, is really all about probability and how to calculate probabilities.